All right, welcome everyone to ASRG webinar. Today is the 28th of May. Today we have a really interesting talk coming about dynamic trust models. But before we get into that, as always, we have a few things that we'd like to ask you first of all. Since we're going to be talking about trust models today, we would like to ask you a few questions about trust. But first of all, as always, we want to ask, well, where are you guys joining from tonight? So if you can just go to polev.com/ASRG. And this is completely anonymous. We're not here to track you guys or anything. We just want to understand, where you guys are joining us from tonight, to see kind of where we're making an influence in the world. So if you can go to polev.com/ASRG and then you can just kind of touch which country you're joining from tonight. I can already see some people coming in from India and Romania, I believe. So very cool. Germany, great. Thank you. And stay in polev.com. Okay, just stay there. We're going to have some more questions for you. Looks like Detroit as well from the US. Welcome, guys. Germany, great. And while people are starting to select some things, um, this just want to start looking. Look at Egypt is also coming in. Really great, guys. So now just stay in Poll EV. We're going to start talking a little bit about trust. And tonight we have some today, wherever you might be in the world, we have some questions about trust. And not specifically about security in any sense, but maybe about first, what does trust mean really for you? And one of the first questions we have is, okay, who do you really trust most in your life? Is this someone in your family? Is this a pet? Maybe a dog? Is this your cellmate or something like that? Hopefully it's not a cellmate, but you never know. Maybe a best friend. Just the idea here is to understand what type of relationships actually invoke trust. And so um, I think as most of you probably, um, the people that you do trust most in your life are usually your family. It's a little bit difficult to trust a dog, and even more so from a cellmate probably. A best friend is also someone that's a little outside of the family nucleus, so that also might be an option. But if you can see here, it looks like 100% of the people that are answering are saying really that the family is where most of the trust is used. And we have one or two people with the dog, so maybe since the dog can't talk back, he's a good listener. Or he can't share your secrets anywhere else. So, okay, we have another question for you. And the next question is, how often do you get disappointed per week? What kind of, I mean, in the context of trust, how often are you getting disappointed by not trusting someone or trusting something? So if you could just kind of give us an indication here of what might cause disappointment or how often you're being disappointed per week, it'll kind of help us understand, you know, the result of not being trusted. And you can see some interesting answers coming in. So the first answer is 1 to 3. So I'm disappointed 1 to 3 times per week. Okay, maybe 4 to 10 times per week is the second answer. And then I'm always disappointed. Okay, that's a different approach. Hopefully, that's not always the case. And 43% or 38% now are saying that they're never disappointed. So at least the results here are showing that okay, 1 to 3 and never are the main answers. Okay, and one more question before we dive into the presentations. Um, so when we do have trust in someone and that trust is broken, how long does it take for you to forgive someone? You know, I know it probably depends on what it is, but in general, how long does it take for you to, you know, be able to let that go? And I know everybody's probably saying, okay, what is going on here? I'm probably in the wrong webinar because what does this have to do with automotive security? But I promise we will get to that point here soon. Um, so the first answer is just a few minutes. Second answer is a few days, a month at least. Never. So sometimes it's just not possible to forgive someone or whatever might have happened. And of course, the best answer here that I love is I love my cat. You know, nothing to do with the answer, nothing or the question. 50% said basically I love my cat. So, all right, very good. Thanks, guys, for kind of playing along. This helps us build this relationship with you guys to allow you to have some interaction when it's in a webinar format. So we try and do this every webinar so that we kind of can see who the audience is, where you guys are coming from, and of course, you know, just to get this feedback from you guys. So, I think let's jump directly into the presentation about ASRG. First of all, before we jump into the presentation with Mirko, I just want to run through some what is ASRG. So it didn't move. There we go. So first of all, welcome. This is the ASRG World Webinar Live coming to you from Germany in Stuttgart. Today we have a really great presentation about dynamic trust models for mobility. Mirko Ross from Asvin is here with us today. He's going to be going through the main topic. My name is John Heldreth. I'm the founder of ASRG, Automotive Security Research Group. That's what I do in my free time. Of course, during the day, I'm the product security lead at Porsche Engineering. So you can follow me on LinkedIn or Twitter or whatever I'm on all the social media platforms. So please find me there as well as Zing. Very good. Going directly into what is ASRG, what are we trying to accomplish here? Um, so the sorry, I lost my spot here. ASRG is a non-profit company focusing on the advancement of automotive security industry. So this is a community, and this is a community for you, for the members. And we're here to help you learn and support the advancement of understanding regarding secure automotive products. This could be charging stations, it could be vehicles, it could be a little bit of the back-end systems, but basically all of the different aspects that go into creating secure products that are going to be used on the market. So we are trying to remove the boundaries that can occur in the automotive security industry. This could be communication, could be borders, finding ways to learn solutions or making good decisions. Because basically, at the end of the day, we all have the same goals. We're all trying to keep our customers, which could be our families, our friends, whoever it might be, we're trying to keep their data safe and secure, which can only be achieved together. We, ASRG, focus on three main areas of development. This is here knowledge, networking, and collaboration. For knowledge, we try to ensure that the people that are working on automotive solutions have the resources, the competencies that they need really to make the best decisions, or at least to give the information to other people to make those decisions. Basically, where to find information, how to learn, building up your own competencies, not only so that it can make you more marketable as an individual in the industry, but that our products and that our solutions that are integrated into the automotive products are done securely. Regarding networking, if you can't find the right information, then having this network of professionals is very important. They might know where to look, have experience which you can't read about, or be able to make recommendations. I wouldn't go this way because we had issues here. But the idea here is we can't know everything ourselves. And if we wait until it's in the resource material, in the security community, this is already way too late. So we can't know everything ourselves. However, as a community, we are stronger. Today, we can support each other. And the last point is collaboration. Since ASRG is a nonprofit, we are an unbiased resource and offer a space where members and sponsors can innovate outside of our companies. This innovation is organized into projects. Some of these projects include stuff like threat intelligence, or we're working on an ASRG portal for the members where everybody can kind of find wiki pages and resources and training material and so on. So all of these different projects are helping develop value for our members. If you want to get more involved and create an impact on the industry, please get in contact with us. I'll show you some links later, but you can also reach us at the email hello@asrg.io. So then, just quickly, ASRG, we have 22 locations currently. Okay, that's really cool. We have over 3,500 members worldwide. So if you're joining us from a location and you didn't realize that there's ASRG locations everywhere, get in contact with the local chapter, local locations, and build these relationships, build the context, the networking, and so on. That's the idea. Also, if you don't see a location near you specifically, and you'd like to have ASRG in your area, this is also a possibility. Just get in contact with us, info@asrg.io, and we can talk about what makes sense for your location. So how do you get in contact with us? The best ways are to get in contact over Slack and Telegram. These are, real-time communication tools that we use to facilitate our worldwide communication. So take a screenshot here. This will also be in the description later as links under in the YouTube, or you can also go to www.asrg.io. There are also links there as well. And of course, following us on social media, keeping in contact with the news and what's going on. We've selected two platforms where we really give out this news, and this is Twitter and LinkedIn. So please join us on Twitter or follow us on Twitter and follow us on LinkedIn, I guess is the correct terminology. Um, and here's where we post information about what's coming up. When we see like news articles about vulnerabilities or threats or whatever, these are the best ways to keep in contact here. We are working on a threat management tool, and this will be also available for members that you guys can also always have access to the latest information regarding automotive security threats, which are being actively exploited in the field. This will come soon. I don't have a definite date yet, but follow back on asrg.io and all the information will be posted there. Very good. The ASRG, we have a weekly webinar. We didn't plan a weekly webinar, but we just had all of these topics, and during Corona time, why not? So, June 4th, so next week, we have a telematic control unit in security with Geoffroy Palou. He is coming from Vodafone, going to be really interesting. June 11th, ISO 21434 by example. This is the new cybersecurity norm for automotive products. Basti Kruk from ETIMIS is going to be going through that and showing some examples of risk assessments according to the ISO standard. June 18th, attacking cars from the cloud, the API way of stealing cars. Vangelis Steikas from Pentest Partners is going to give us a really interesting view about going through the cloud to get into the cars. June 25th, we're still discussing the title here, but Christina Lacati is going to be with us from Cyber Risk, and she's going to tackle the topic of IP. And security is not only about implementing technical solutions, it's also about ensuring that you understand where your greatest threat is. And that's usually the people that are working on implementing the controls in the product itself. So we always need to be careful there. Christina is going to go through that. July 2nd, we have CAN bus versus Ethernet IDS IPS. This is an intrusion detection system, intrusion protection system for CAN bus versus Ethernet. Very interesting topic here. Gilad Bandel from Arlu is going to take us through this topic. So we have lots of interesting stuff coming your way. Check back with us often, and there's going to be a webinar every week. Okay, sponsors, we also need support from sponsors. ASRG is free to the members, okay, and to keep this going, we also need sponsors to support this. So we really do ask that people are giving or looking into the opportunity of being sponsors. If you have ideas or if you have a point, please let us know, because ASRG offers global branding, a specific targeted market, access to exclusive content, post opportunities, find talent, and in today's industry, this is not so easy. Again, hello at ASRG.io, and we'll discuss. All right, so I promise that's enough from to me for tonight. Now is on to the interesting topic, and we have Mirko Ross from Asvin here, and he's going to talk to us today about trust models. So, Mirko, it's up to you, sir.
Okay, thank you very much for inviting me, and I will talk a little bit about the dynamic trust modeling. And as you have seen at the beginning with the questionnaires we had, the questionnaires had been about trust in social life, and hopefully I can show you the next couple of minutes or for the lecture what does trust mean from a social level, of course, but how does it impact the technical level? And by that, again, how does it go back towards as we are users of technology, and what does it mean? So, but first of all, let's do a brief introduction to myself so that you know who is talking here. My name is Mirko Ross. I'm CEO of Asvin, which is a company as well here in Stuttgart. And we are taking care of trust and security in the software supply chain and software lifecycle. So that's our main topic. And even as we are located in Stuttgart, of course, there are some relationships and some connections to the automotive industry, as Stuttgart is one of the, let's say, global big players in the world as a town and towards mobility. Beside working for Asvin and even bringing that company to success, I'm a long time active in the cybersecurity area. First of all, I'm really active, since the beginning, like the first computer. So I was always a hacker and a maker, and trying to understand computers, and even like trying to understand even servers and what's in behind. So, but I've changed the sides from it being a teenage hacker towards professional cybersecurity researchers. And research means that I'm now really active on several expert groups and several levels. First of all, I'm part or member of the cybersecurity expert group at the ENISA, which is the European Cybersecurity Agency. And I support the team there when they are releasing, for example, the white papers and recommendations as an expert by reviewing or giving input. And I'm quite active on several European research projects which are in the area of cybersecurity. So, for example, currently at IoTCrawler, which is a safe research project on how to do search safe and secure in IoT assets, which is a big topic because we know the unsecure way is showdown. This is not the best practice, but for large IoT networks, we need new possibilities and tools and methods to create search, which is in a way like secure from a cybersecurity level, but as well respecting, for example, privacy and all this complex stuff. There's another research program we just finished. It's IoT for Industries, where we were working on secure bootstrapping of IoT assets and large heterogeneous IoT networks. And now with Asvin, we are working on a new project, which is as well a German-funded research project where we are using physical unclonable functions, PUF, to create IDs in IoT networks. And as this is one basic of ID management, there is another project which is called disposable IDs, which is dealing with self-sovereign IDs, which is a big topic, like who is owning the ID. And for that, there's as well now a larger research group which is working for disposable ID systems. This means like ID is something which is rather important, and it's a rather, let's say, important asset from a personal level, and you don't want to maybe share this rather important asset with everybody for if it's a low trust, for example, communication. And by that, you can create this kind of disposable IDs, which is a one-time ID. You can just use this one-time ID for communications and assets for low trusted communication. So And this is leading me into the topic for today. So I was thinking like, how do we start talking about trust? And I think the best to talk about trust is to talk about zero trust and why zero trust has become so popular in the cybersecurity space. And this is, I think, like many of us are thinking today about trust, and this is a zero trust model. So we have there one of the fancy administrators standing in front of up on its fancy firewall, and then you have all these untrusted zombies knocking at the wall. And as you are a very good administrator, you can be confident that no one of the zombies will manage to break the wall. So all the assets behind the wall are trusted assets, and all the other assets which are outside the wall are the untrusted assets. And this is it's an easy world, I think so. Even it's complicated enough, as we know that there are several attacks running towards our networks, but we have a rather simple approach that we say, well, first of all, zero trust of everything, then we decide which kind of assets we can create a certain trust, and then they can operate together in behind of these compartments. I think this model is easy and it works on an easy level very good. But the problem is that our world is turning more complicated. And I think security in IoT, and even like when we talk about mobility, is something more like this. We cannot keep the zero trust attitude anymore because the world is getting more complex. We have more devices who are arriving, and this is not only simply more, it's a massive more. I mean, if we want to leverage of all the opportunities and advantages of the connected world, even in mobility, we need to accept that we have to talk with millions and billions of devices in the future. And by that, it will be impossible to keep up zero trust models. Why? Because then we will have too much uncertainty in the systems. And even if we keep up zero trust models, we can't be sure that some assets will be getting behind our walls and compartments, and then they will be part of our system and will compromise our systems. I mean, that's why we are now building all this fancy intrusion detection stuff and to try to find out anomalies. I mean, these are clear signs that the world is getting more and more complicated. So security in the IoT as it's today, that's I think. We are facing a lot of assets and a lot of security threats. So if we come back to the zero trust models, I mean, why is zero trust not working perfectly for this new world? And there are two good answers to it. One answer is that you can say, well, it's already a complex problem to keep security and trust in kind of that systems. And with zero trust, we are adding, unfortunately, more complexity because we need to take care of all the devices who are in the system in terms like if we want to get into a communication with them, we need to be assured that these devices are, for example, updated or patched and stuff like that. But we can't be sure on that anymore. Because if the systems are heterogeneous, if the systems are complex, we are increasing the threat levels, we are increasing the surfaces, and even we can be sure that this complex problem can't be challenged when we try to add more complex technology on top of this. And the second one is that within peer-to-peer networks, and I think what we are facing more and more are peer-to-peer networks, we see that this is getting much more incompatible with this kind of layered zero trust network models, where you can say very clear, this is your network area. I can control every device which is in the network area, and I can decide what kind of administration level I will grant to a certain device. On peer-to-peer networks, where the relation between the objects and the assets are getting more and more flexible, and there's a requirement that they're getting more and more flexible, you can't control that anymore. And even like we're getting missed from this kind of centralized instances or cloud services, which can keep control on top. Like, remember the system administrator standing on top of its firewall and just watching the zombies arriving. I mean, if it's a physical human system administrator or if it's an AI-based intelligence enterprise expert system, no matter why, the approach is getting rather critical at the edge because the information at the edge is not available to run the systems. So we try now next to bring these layers into the peer-to-peer networks. So zero trust seems to be a little bit critical. Even if we look in a car, and that's now a question like what kind of entities we can manage with zero trust models, then we see, okay, if even like the car, as we know, is changing its landscape in terms of the network, I mean, it's still something you can manage. And I think on that level, you can implement zero trust models in terms of what kind of components are allowed to run with certain levels of authentication and user management rights or privilege inside this kind of car system, as we see it as a local area network. But if we see it, for example, on the level like what we see now with the FPGA computing technology, so that even like on a hardware level, there is no defined state anymore because the microcontrollers are changing dynamically and can be dynamically programmed in terms of their initial inherent state, how transistors are working. I mean, it seems to be that we also have to get away from the idea that in a complex local car networks, we can keep up zero trust models because it seems to be that there is no static idea of how trust can be modeled anymore, especially, for example, with the FPGA technology we see there. But however, maybe we can, with a lot of efforts, we can keep it up. Then it's a pretty cool local area network where we can say for certain vendors or suppliers or supply chains, let's keep it zero trust as much as possible. But what if we take this car into a smart city? I mean, the smart city is raising the complexity, it's raising the assets. If we talk in a car maybe of a few hundred assets or a few thousands assets who needs to be synchronized and needs to be on a certain trust level and need to be controlled, on a smart city, everything will be out of control. We are not talking about thousands assets. We're talking about millions of assets or billions of assets who will be part of the connected city. And a car and all the mobility elements, they need to be part of the smart city. And by that, I mean, the effort to keep these things up to date, to keep these things running, to keep these things without certain vulnerability, even to make a patch management on a smart city is impossible. We need to accept that the assets in the smart city will be vulnerable. So if our car is talking with other assets, we need to be, or we can be sure that it's not clear if this asset has some certain vulnerabilities, yes or no. If the asset itself is not providing more and more information so that we can do an estimation of trust. And that's why we now come into the concepts and idea what's in behind of dynamic trust modeling. So first of all, let's say if this controlling is getting more and more pointless, if these resources are getting accessing this kind of vulnerabilities, how, from a zero trust perspective, how are you able to give a vulnerable application privilege? It's impossible, because if you give privileges to vulnerable applications, you're just in a way that you're getting you're just owning the vulnerabilities from third-party assets. So this is really critical. So I think on this examples, especially like when we step into the smart city area, we'll see we have to accept that we need to deal with the vulnerabilities of assets, even like, and this is a rather social approach, and that's coming back to the question John was doing at the beginning of the webinar. We have to accept a little bit that building IoT networks or building mobility networks from a technical level is rather similar like how we build networks from a human perspective. So maybe we have to accept that the defect is the new normal. I like it as well because everybody is talking about new normal, and we are in times where defect seems to be as well bringing us into the new normal. But for connected devices, defects in terms of vulnerabilities, in terms of outdated software, in terms of outdated software life cycles, this will be the new normal. So even if a ship will be loaded perfectly, like we see it here, we have to accept that maybe this kind of systems have the tendency to get out of balance. And the question is how you can deal with a system which is always try to get back in balance or is getting out of balance. I mean, we can't deal with that with static models. What we need are dynamic models, even in the cybersecurity area. So coming back to social relationships and even like to research in the social space. And I think it's fascinating because the relationship between humans, believe it or not, it seems to be more complex than the relationships of technical assets and even in the IoT. But however, as humans, we have managed to deal with relationships because if we are not able to manage relationships, I mean, this is a matter of our existence. We are forced and needed to manage relationships. Otherwise, we can't exist. And we have invented by evolution, we have invented as a solution for dealing these relationships, and this solution is called trust. And now the big question is, okay, what is the core idea of trust? And the core idea of trust is, well, look, it's a complex world. There are complex relationships. We can't deal with that, but trust is a possibility to reduce the complexity of these relationships. And by the way, we are reducing complexity because we are talking only on the level of trust. We can deal with a complex world. And that's, I think, like from the social perspective of humans, something we can transform to all the challenges we are now facing in mobility and even with this interconnected layers we are now facing. So if we look on the idea of dynamic trust modeling, I mean, to be honest, there's already a lot of trust modeling out there. If you look in the finance industry, trust modeling in the finance industry, like ratings, have been already introduced since a long time. The problem with ratings in the finance industries is that these models are rather centralized. This is one weak approach, and the second approach, that they are less dynamic. But at all, the finance industry had worked for many years very, very, very good with their scoring models. And even if you are a consumer, you know that you are scored on a more dynamic level when you go, for example, for online shopping for the checkout today. So it seems to be that the finance industry is dealing since a long time with the question of trust by implementing scoring models. If we look at IoT and the question like how IoT assets can communicate in a way, modeling of trust is, I mean, described, but it's less implemented. And that's why we have shifted in the past to zero trust models, because it seems to be like, we need to identify the way how we can build this kind of trust layers. And even now, I think some building blocks in terms of technology have still missed. But now we see that these building blocks have been created or are in creation, and which brings us to the level that we can step into the area of dynamic trust modeling. And for dynamic trust modeling, we need some certain building blocks. One important building block is, of course, always the identity, like who I'm talking. Even as from a device perspective, is this really the device I can expect? And for identity now, we have a lot of solutions out there which are working on different ways. I mean, like if we take this classical way to deal identity with certificates, to give trust by a certificate to a certain ID, which is a high value identity. On the other layer, we see other concepts like what we are doing with the unclonable functions, for example, that you can create fingerprints of certain devices just in the way how these devices have been assembled. Because each device has some unique elements inside, even on an electronic level. And by that, for example, you can clone or you can create unclonable identities based on this rather individual ways of how certain devices are built. I think for car manufacturers, they don't like the idea that cars are still not perfect, but on a level, on a really close level, every car is different, and this can be also applied on the software level of cars. And for example, you can create unclonable identities in terms of some certain elements, how radio frequencies are used and stuff like that. So identity is one part. Second part, your user's experience. You need to know, for example, have you been with this device in the past together in any communication? What kind of communication has been established? So you need to memorize the way of communication. And with this memorize way, you can just get back to your experience with a certain communication level of a certain device. And by that, you can use it as well to calculate, to use this for scoring and calculating trust. The third important element is references. And even like keep in mind from a human level perspective, it's exactly the same. It's in references. If someone like a high trusted element is telling you that this element, you can trust this element, you can consider it in a way for your own trust models. So in terms like, let's take a car, if some certain elements are part of the main building blocks or from the main, from a group of supplier, you already know that they are running perfectly through all this trust audits and security audits and stuff like that. Of course, you can say, well, this certain assets inside a component or inside a software architecture have another state of trust than components which would be included the first time and with no references, for example. And the last but not least, it's reliability. The question, for example, if you establish a connection inside, is this connection stable, yes or not? Is the element you connect supplying the data you are expecting or which have been agreed in terms like APIs, yes or not? And even like integrity, has the data some certain levels of integrity? For all these elements, they are now, in the last years, we see there are now really brilliant research results out there on a level of how you can take these attributes to calculate some certain level of trust. There's one example here for integrity where you can say, well, you can create a score on an integrity of a certain device or a set in the IoT if you take some certain levels of attributes you can collect, and then you can create from a scientific level really objective, good scoring, for example, for integrity. And you can do this for as well all the other parameters which are part of the trust, and then you have a scoring metrics, and you can use this overall scoring metrics to define certain trust scoring system. And at the end, of course, like if you have this kind of dynamic trust scoring system, you can put this trust in your own rating model, and then you can say, well, there are some certain levels where you can say it's an excellent trust, or it's an average trust, or it's a bad trust. What you need to understand is that the scoring is always individual perspective. So each device which is creating a trust scoring from another device can put in their own criteria in their metrics to create, let's say, to create their own weights. So like a device A has some other weights on trust than a device B. So it means like device A is maybe more defensive, so it will take care more on, or will be much stronger on weighting, giving devices a lower weight than a device which is, let's say, not defend, has no more a less defense attitude, and will be more open to establish connections and stuff like that. So it would be give more higher weights on certain scoring in the matrix. So you have to understand even that is a rather independent way from device to device, which can be set. And this is even like as well like in the human nature. I mean, we have people who are trusting other people more, and we have people who maybe distrust more. And the weight inside IoT devices or inside the devices can change. The way of weight can change in terms of experience. If you have some certain bad experience with groups of devices or assets, you can dynamically change the way how you make weights. And this is rather similar to social modules we see in human nature. So if we see, well, in terms of dynamic trust models, what is changing? We're coming from this kind of rather centralized systems where this static trust or zero trust models could be easily implemented. Then by that we are moving it to a more decentralized way. But at the end, if we see the smart cities and all this rather high dynamic environments where a lot of connections and devices need to interact, the only or the perfect way to deal about trust is dynamic trust modeling, because then certain nodes inside the network can decide if they want to establish a connection with another node. And even they can decide if they trust the data or the services which are provided of this node. And this model gives you the guarantee. I mean, even like if you don't trust one node, you can just connect, for example, to other nodes, because for some certain information or services you require, there's not only one node serving this information in this high-level IoT environments, there will be many nodes available. It's just a question which kind of nodes has the higher trust level for your use case, and then you're trying with the node with the highest trust. If you see it in terms like in terms of trust scoring, how these nodes are then operated, then you can see, well, there are certain nodes. It's always here in this idea of a bidirectional communication. And then even you see that the trust weight between the nodes is not the same in terms of the direction of the communication. And that's rather clear, because every node in the dynamic trust model can decide from its own weight matrix the level of trust. So it seems to happen that two nodes who are in communication have a completely different idea of what is the trust level of the communication. But from an objective perspective, this looks maybe wired, but from an individual perspective of a device, it's a logical consequence. So keep in mind that for a trust scoring of mobility assets, I mean, that's exactly what we see in this kind of scenarios where we have car-to-car communication, or communication, for example, with traffic systems. We have communication with sensors who are placed outside. The question of a certain, for example, car in this scenario do I get into a connection of a certain node? It's a question of, can I trust on the first level to create a connection? And secondly, can I trust the data or the services which are provided there? And if a node has a bad reputation or some factors are rather critical, even a set will terminate the connection towards it. So for example, if a node is like classified as a high vulnerable asset, you can immediately decide to terminate the communication, and by that you're preventing yourself of getting harmed by getting too close in communication with this kind of certain nodes. So by the idea of dynamic trust models, all these assets would have the possibility to negotiate the terms and the level of trust inside this kind of systems. So there was a little bit of question like, this is basically what we are working on. And a question like, okay, but how can you provide it, for example, on real cases? And what we are doing, for example, on our real cases is that we say, well, first of all, to create this kind of dynamic trust models, what you need is information and you need transparency. Information needs is a question of, can we track the way, for example, how software on certain devices are applied? And this not only in a way like there is a certain software installed, no, can we track really the whole supply chain of a software? It means like the software which have been deployed, a software which have been certified or was running on a certain audit, it was distributed over the air, for example, on a mobile asset, and then it's running on a set. Can we track this as a whole process? Yes, it's possible to track it, and even as it's let's say an edge case, it's rather clear that with centralized system this will not work very well. So there are decentralized ledgers where you can store this information in a cryptographic way. So by that, it allows to create audit trails on and histories of how software, for example, on a device was operating. And even you can track, for example, what kind of connections this device is doing. As it is on a ledger, the device has the possibility to keep this information decentralized on its own asset, and even to share it with everybody who is inside the network who can access the ledgers. This information, for example, you can take to create a first trust modeling and scoring. With the methods I've shown above, there are now a lot of mathematical methods available, and then you can create two ways to provide trust scoring. One way is that the device itself can provide a trust score, which let's call it a self-audit, which is fine as long as the device is not really vulnerable or insecure. But of course, the best is if other parties can access the ledger and then use the ledger to create their own trust scoring. By that, you need transparency. It doesn't mean that you need to provide the confidential information on the ledger, but you need transparency, for example, in terms of give other parties the possibility to check what kind of firmware is, for example, running on a certain device. Is this a Linux stack, for example, with a certain Bluetooth vulnerability, yes or no, so that they can do their checks. By cryptographic methods today, you even do not need to unveil this information as a clear text in the ledger. I mean, there are many methods out there where you can provide a certain information and even give other parties just the possibility to apply their functions on the ledger to get the information. For example, is there a certain firmware installed, yes or no? But even they will not get all the information about what is really inside the firmwares of the certain devices. But at all, you need a transparency, and you need let's say, brave enough to allow to store this kind of information on public ledgers, even if they are secured in a cryptographic methods. But if you have this information available and keep it available, you can allow other parties to leverage from this information to create their own trust scoring. This was one example how, for example, we are showing this kind of software life cycles in our system. So if the devices and assets are registered here on the platform, you can really go through an audit trail through all the critical or to all the events which are around a certain software part which have been installed. And as this information is stored in the ledger, you can leverage from this information to create your own dynamic trust models. So, like, I mean, I hopefully I gave you a little bit about an idea on how the world maybe can change if we are getting more to flexible ways to even disclose some certain information of our devices in a secure way. And by that, I think it's like even coming back to Niklas Luhmann, who was one of the great social researchers of human relationship, and he did a rather lot of works on trust. And he said, well, that trust is not only the foundation of the world, and this is really, I think, fitting perfect to the connected world we are facing. It's also a structured view on the world. And by implementing this kind of dynamic trust models, we are implementing really a structured view, which is not only from a cybersecurity level or perspective on how secure is a device. At the end, we can really say, I mean, how secure is our world which are surrounding us? How secure is a smart city? Because even from that level, there will be different ideas of trust. So, and if I step a little bit more forward, like if we see all these flying taxis and stuff like that, which will be maybe a future, the future will bringing us. I mean, stepping into a flying taxi, which is autonomous with an autopilot, will require a lot of trust, isn't it? Not only trust in the vendor, but also trust in the security of all the systems which are surrounding us. Trust of the city we are in. Is it a major fucked hacker city we can approach, or is it really a safe and secure city in terms of cybersecurity, where all the assets are really aware of being patched and updated? I mean, as this might be not possible to keep everything updated, we need this kind of trust. And stepping into this autonomous vehicle, we need trust, or we need this kind of balls of steel. So, and by that, thank you very much. I hope you had, I can give you a little bit of insights of what we are working on a research level and product level. And I'm just open now for answering questions and getting into the discussion.
So Mirko, first of all, thank you very much from my side. Very interesting concept, the dynamic trust models. Before we start answering questions from the audience, so if you do have questions, please go ahead and you can type those in the live chat in the YouTube, and then I will speak with them with Mirko. So if you do have questions, please type them in there during this time. And Mirko, I have a few questions that I've written
Yeah.
down myself. I really like the slide where you have these kind of a centralized trust model, and you have kind of like this okay, we trust a few people in our network. Exactly. Slide 14.
Yeah.
Right.
Yeah. 14. Yes.
I really like this. And as we slowly move from this like centralized concept to a decentralized into a very dynamic model, um, first of all, I was just wondering, so what types of challenges are we going to see before we get to such a dynamic trust model? Is there something that we need to accomplish before this can be realized in the field?
Yes, I mean there are two challenges. One challenge is like, let's say it's an attitude challenge. Like if everybody is still thinking in compartments, we're not getting. We're still, let's say, somewhere in the middle. To me, that's a little bit the compartment model. Compartment means like that certain vendors will try to protect, of course, their assets, which is all good, but will not share too much information about the security levels of their assets.
Mm-hmm.
And by that, I will be not able to do an assessment on the trust of these assets. I mean, we see it in industries a lot of time that people are still ashamed, for example, if they have vulnerabilities. I mean, but to be honest, it's, as we all know, there is no system with no vulnerability.
Mm-hmm.
If we don't share dynamically the information about what kind of vulnerabilities, for example, are affected by some certain assets, and if we keep it in this kind of compartment level just inside the vendors, I think we get stuck somewhere in the middle. That's one issue. The second issue is it's of course about interoperability as well. It's not only about transparency, it's also about a question like interoperability. Can we agree on some certain open standards in terms of interchanging trust and dealing with trust? I mean, there are a few organization and activities out there who really try to make an approach like getting interoperability on this kind of systems. And if we have the interoperability and the standards, we can get to this kind of full network, flexible dynamic trust.
Yeah, I really like the point about using intelligence from the field, vulnerabilities and information about what's happening in the field to affect your dynamic trust model. You know, because if one node is compromised, and automatically those values can be updated, and in a decentralized type manner, so that you can automatically take a node out of the dynamic trust or trust it less.
Exactly. I mean, the idea is something like if we talk in IoT devices, I mean, the problem is that too many systems we are now building are really still in a, let's say, static trusted in a static way. So all what we then try is to detect anomalies, let's say in terms of the data connections or the data flowing from the nodes. But still the consequences are not clear. It's something like the consequences, okay, we take this node out of the network or completely set node out of the network, okay. But we have maybe our automatic analytics, but we have still non-automatic consequences on this. And I think what we need is we need a dynamic model which just say, well, if a device or assets or fleets of assets are falling under a certain trust level, other nodes can decide by themselves if they want to stay into connection or if they are looking for new partners to get the services or information.
Okay, and so when we talk about automotive related assets and stuff like this, we usually look at the vehicle ourselves, and inside the vehicle we have a lot of different ECUs, right?
Yeah.
And um, my my question, we do risk assessments and stuff like this. We try to understand what type of potential risk we will have in the field with this product. Where does trust fit in with risk? Is this something that's coming with integrity or authenticity, or how is this comparing to the goals that we use in risk assessments?
I mean, first of all, I think the problem with risk assessments is that they're less dynamic, isn't it? It's like, I mean, you have like take the ECUs. Of course, you have a certain standard, like what kind of software components you're running on an ECU or what kind of algorithms. But now, as we see, the technology is progressing much faster. Like if you take the FPGA situation, where you can say, well, even now it's hard to predict what is the current state of a hardware. I mean, because with the FPGA, the transistor level can change on a certain chipset. I mean, this means that the hardware is going into a dynamic situation. And then I think how to bring in your cybersecurity risk assessment, which are made on a certain state, into a car which have dynamic hardware components. I think we need another model for that.
Well, and definitely not some type of Excel table, right?
Yes, yes, exactly.
So we need models as well to be able to evaluate trust, because the trust is, or I'm sorry, the risk,
Yeah,
excuse me. But from my point of view, we also need models to evaluate the risk, because risk
yeah,
is something that should be changing over time. It's not
yeah,
a static number that you take a picture in this point in time and it doesn't change. The environment in which that product is working or is operating is the result of risk, because it's a function of risk. So continuously over time, the risk of a product is completely changing based on the variables in which its operating environment is.
exactly. And this is a little bit horrifying in terms of if you come back to the European perspective. I mean, there is now like the European product liability or directive, like the question on what is a product and how vendors are liable for a product. This directive had been designed in the 80s. I mean, this was like, wow. And now there's a big need to change that directive because this is all about risk. It's how to protect consumers from the being harmed from a product. And if we think about connected systems, it's getting so complicated. And if we bring addition, like the FPGA is on a hardware level, but if we bring in artificial intelligence and machine learning and stuff like that, I mean, it's getting more and more complex to say, well, what is the current state of a product in terms of risk? And how can we bring that into models of liability or models of safety, product safety?
Right. And even as we talk about connected cars and actually broadening the amount of information, or even the sources of different information, it's instead of the car building a connection to the back end and saying, hey, listen, what's the temperature in the area, or what's the temperature in Stuttgart? Um, Instead of doing that, the car could ask another source, hey, what is the temperature in Stuttgart? Before he hasn't built this trust yet. And this is this concept of how can you build trust with external sources of information that maybe were not considered to be trusted before.
Yeah. And there is something like from a research project we are involved, where it's not mobility, but it's about critical infrastructure. And this is exactly the question, like if you are I mean, you're doing your prediction of how the system should behave in terms of data set, which are provided by third parties. And now the question is, can you trust the data sets, yes or not? But as we know, the question of trusting data sets is so complex. I mean, the best way would be maybe to say, well, if I have a dynamic trust idea that I can't trust a data set for this kind of critical decision I need to take, I need three resources, other resources to validate the data. And but doing that for all decisions will bring in too much, for example, latency, or will be too complex in terms of bandwidth you need. It's not necessary. It's only for some certain decisions you really need to say, well, I need, for example, a 3 data point policy where where I need 3 trusted, let's say, certain trust level data points, and then I can feed my algorithm to make a decision.
Well, and that could be even different, just like risk for different companies. So having these trust models, how do I trust?
Yeah.
But we do have some questions coming in from the audience. The first question was, okay, first of all, what is your experience in using COT components, which components off the shelf in vehicle software, especially with respect to reliability? I think the question is going in the direction of, okay, using components that are already developed without keeping these types of trusts, behaviors, or relationships in mind. How can we in the future um, build trust in without changing the components, or is there a nice middle point?
I mean, this is the big question the whole industry is facing, like between OT and IT and stuff like that. I mean, how can we build or how can we make the stuff secure if we have still components in there which we know they're maybe from a safety perspective they're working perfectly, but from a cybersecurity perspective they have some critical points or stuff like that. I have no good, unfortunately, I have no good answer on this because it's there is still one method to say, well, however, I need the compartments around these components, and I need the supervising and monitoring layers around these components because I don't get an inherent way of trust modeling. So that's the unfortunate answer here. Of course, with involving technologies, we would like to see that the majority of components, because they're getting, I mean, they are getting more computing power and more stuff like that. So, of course, this kind of models can be implemented in the future. Even like if we look at the ECUs and even on sensors, I mean, what we see at the edges, even that we see virtualization is stepping in as well. And why not? It's unfortunately but not a good question for the current situation.
All right, no problem. So the next question is, so Gottfried, does the idea of decentralized trust not need device IDs or other IDs for other components? Putting,
Yes.
okay, so go ahead.
First of all, I mean, we need IDs. So that's rather clear. And that's like what, I mean, what we are doing or I'm doing in the research as well. I said I'm rather deeply involved in the ID topics as well. First of all, of course, trust starts with the ID. I mean, we need to identify our partners. If we can't identify them, we're getting into trouble. The question is for the IDs, and that's the rather interesting question. I mean, do we always need, let's say, not for all communications from an ID server, I need to present my super high integrity ID in terms of, let's say, this is a super valid ID, which is rather important because I don't want anybody to clone this ID or to misuse my ID for any actions. And that's for what I said at the beginning, like from the research activities, that's where we are working with the disposable ID concept. That we say there are sometimes, let's say, one-time connections and transactions where you can create a sub-ID of this kind of super master IDs with high integrity, and you can use the sub ID only once a time for a certain connection and action you're performing there, and afterwards you can dispose it. Which means this ID can't be used anymore from inside the systems. And this is a concept which I rather like because it protects the super very important high integrity IDs from being exposed to, let's say, low trusted connections.
Okay, very good. And the second part here, He has putting some information into a DLT is easy, but the identity of components has to be verifiable.
Yes, totally agree. And that's even like, I mean, we see different concepts out there towards how we can verify the identity of components. Once I said it's about unclonable functions. For example, can we bind certain ID elements towards unclonable functions of a set? And there are some certain levels where we can identify, let's say, a fingerprinting of a set. It could be a hardware way how a set is built. The second one is the way of application, how a set is running. And by that, there are some certain possibilities to identify even an ID if it's written in a ledger, and link this to a certain device.
What in so has this authenticity of the information, is this a part of the trust model? He's asking further, this ID component, is this has the authenticity of the information been addressed in the trust model?
Yes, we do it with the like, for example, when we say, well, a certain let's say a certain ID or has been authenticated by a trusted party. This can be part of the trust model where you say, well, this ID with this certain certificate um, 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 can be shown as well, or can be retrieved as well from the ledger information, and you can use it to build your own trust models.
Okay, very good. So Mirko, I don't think that there's any more questions coming from the participants. And to be honest, I could sit here and talk all night about trust models. Uh, but I think we're at a good point here where we can close for today. Um, from my point of view, I'd like to thank you very much for taking the time to describe and discuss about these dynamic trust models. I think it was a very interesting discussion. So thank you very much. If so, would you like to say a few comments before we close?
No, just thanks to everybody in the audience for listening. And if you like to ask questions afterwards or whatever, just send me a message as well. I'm almost available on all the fancy social media networks. You can ask me on Xing, Twitter, or by email. Just do it.
Great. Great. And so don't forget, so contact Mirko if you have more more questions for trust models, dynamic trust models. Um, when we don't forget ASRG Worlds, we have next week, we're going to talk about TCUs. So we'll have Vodafone, Javra will be with us, and we will be discussing about the telematic control unit security. So please join us next week for the next webinar. Thank you very much for joining. Have a good evening, a good day, good morning, wherever you might be in the world. Thank you for joining ASRG. Have a good
Thank you very
evening.
much.
Ciao. All right.